everyone, I am Vishwanath. Today we are presenting the design of turnbuckle. In that, first we will see the what is turnbuckle. In that turnbuckle, one is the middle component and other hand the threads. If we rotate the middle component, as it may be a coupler or any rotating device, then the threads will be come towards that coupler or go away if we rotate in other direction. In the rack system, how the turnbuckle acts, let me see. In that first one we have to install in X brace. If we see this diagram, these are the turnbuckles. This is the rotating part. If we rotate this part, then this will be adjust the vertical brackets. Then it will hold all this rack in tension. That's why these vertical brackets do not sway away. This is working. And now, nature of loading. First one is the tension. This will hold all the tension. That which tension. And second one is the shear press. The threads will go under the coupler. Then the threads may be slip or in the safe condition. And third one is the cyclic loading. While installation of this rack, threads may be under the coupler or outside the coupler. This will be cyclic loading. And fourth one is the torsional stress. While rotating this coupler, the threads may rotate. This is the torsional stress. And material selection. From the design data book, we have choose the IS 2062 steel. This is the corrosion resistant and forging. This is the medium carbon steel component we have chosen. These are the mechanical properties of the material. Yield strength is 250 MPa and ultimate tensile strength which is 410. And modulus of elasticity, this is 200 GP.
Dhananjay Joshi, my roll number is 175. The next point is factor of safety. Selected factor of safety is 3.0. Type of load: industrial racks experience live loads, impact load. A higher factor of safety is needed to absorb this sudden energy swings. Material. We selected IS 2062 grade E250, which is ductile material. Ductile material usually allow for slightly lower factor of safety than brittle ones, but since safety critical structure component, we say service condition. Warehouses are high traffic areas. Threads may wear or experience minor corrosion. Calculation for allowable stress. To ensure you have complete engineering record, let's break down every mathematical step for M20 turnbuckle design. Logic, the variable, and the final safety check for each failure mode. Calculation allowable stress. Sigma all Fy upon N 250 upon 3 is equal to 83.33 Newton per mm square. Meaning, for every square millimeter of steel, we will only allow 83.33 Newton of force. Calculation for tensile strength. The rod is long part of turnbuckle. When racked away, it tries to pull this rod apart like piece of string. Finding the required area, we know that load 50,000 Newton. We need to find how much metal area is needed to hold it. Area is equal to P upon sigma all is equal to 50,000 upon 83.33 is equal to 180 mm square. Finding the diameter, since the rod is circle, use the area of circle formula. A is equal to pi by 4 d square. To find the diameter, 180 is equal to pi by 4 into d square is equal to d square in root 180 into 4 upon pi, 15.14 mm. Selecting the standard size, we don't manufacture custom rods. We pick next standard size for design data book, M16 and M20. M16 diameter 13.5 mm, tall to small. M20 has diameter 16.9 mm, perfect. Validation 16.9 mm less than 15.14 mm. The tie rod is thick enough. Calculation for shear strain. Even the rod is strong, the teeth might strip off. We must take the shear stress. Determining engagement length. The more than rod is squared turnbuckle body, the stronger it is. Standard practice is 1.5 into diameter. Length is equal to 1.5 into 20 mm is equal to 30 mm. Calculating the shear area. Imagine the thread cylinder of metal being shaved off. The ear being shaved is AS is equal to pi into d core into length into 0.5. AS is equal to 3.14 into 16.9 into 30 into 0.5 is equal to 796 mm square. The 0.5 accounts for the gap between the threads. Shear stress. T induced shear stress is equal to load upon shear area is equal to 15,000 upon 796 is equal to 18.84 Newton per mm square. Comparison with limit in engineering metal is weaker in shear than tension. We assume shear strength is 50% of tensile strength. Is equal to 0.5 into sigma all is equal to 0.5 into 83.33 41.61 Newton per mm square. Validation. Since our stress 18.84 is much lower than limit 41.67, the thread will never strip. Shrutika Patil, roll number 176. Today I am going to represent induced stress. Now we check if our choosing M20 rod can handle the load. Core area of M20 225 mm square. Induced stress sigma induced stress is equal to P by induced stress. P by A is equal to 50,000 Newton upon 225 mm square and total value is 66.67 Newton per mm square. Comparison. Induced stress 66.67 megapascal and the allowable stress 83.33 megapascal. Conclusion. Since the induced stress is less than allowable stress, the design is safe. Next one is a torsional stress. To complete the engineering design, we must calculate torsional stress. Calculation for torsional stress. When you turn the turnbuckle body, you are fighting against friction to create tension, and this creates twisting moment in the rod. First point is calculating torque. We use power screw formula to how much torque is required to create 50,000 Newton of tension. Assumption for M20 thread. Main diameter 18.37 mm. Rate of friction 0.15 and torsion is equal to 15,000 point 18.37 by 2 and total value is a 30,300. Calculating the shear stress due to torque. Now we see how much that 30.3 Newton meter twist the material.
Nine.
Combined stress and validation. In the real world, the rod feels tension and torsion at the same time. The formula sigma is equal to sigma t square plus 3 tt square. Plugging in the our values, tensile stress 66.67 megapascal and torsion stress 32.5 megapascal and the total value is 86.75 megapascal. And next part is a final safety conclusion. Now we compare our combined stress against is the strength of material. Total induced stress 86.75 megapascal. Material yield strength 215 megapascal. And the result is a 2.88. Final verdict. Even when we include the twisting force of wrench and the pulling force of rack and the factor of safety 2.88. And the last slide is a conclusion. The turnbuckle serves primary tensioning element with the diagonal expressing system. And the theoretical function is to convert rotational torque into linear tensile force, effectively locking the rack vertical upright into the rigid block configuration. Thank you.